Yeah, hi Jayesh. You can start now.
So, hello everyone. Today's my main agenda is to make you familiar with the lithium-ion batteries. Why the lithium-ion batteries are the preferable choice for the EVs industries, and we will see the modeling simulation part of the battery pack, and we will also see the some of the components which are using for the protection purpose of the battery. So we will move ahead with the first lithium-ions battery, and for the simulation purpose we are using MATLAB software. Lithium ion batteries. The lithium ion batteries, the main charging carriers are lithium ion, and it is a rechargeable battery, and it is a popular choice for the smartphones, laptop, and for the energy storage device. But nowadays, it is more preferable for the EVs industries also due to its advantages because of high energy density, which provide a high storage capacity, rechargeable, so you can use this battery for the multiple time. You can use this battery as per the grade. So if it is not recyclable for the automation industry, you can use this battery for your secondary works. And this battery is also having a low self discharge rate, which is very good as compared to lead acid batteries. Suppose we'll talk about the lead acid battery. In lead acid battery, if we keep this battery standstill condition for a 3 to 4 months, you can see that your battery goes near to dead zone, or you have to replace the battery. But in the lithium ion battery, we see that the low self discharging rate is very less. So whatever the energy is stored in the cell, it have a long time which we can use as per our requirement. One of the major advantages is lightweight. So lightweight make the battery as for the recommended output voltage. Just like I want to need 44 volt or 100 volt. So as per the series parallel connection in strings, we can connect the battery and we will get the correct output. This battery is also having a fast charger. So it can support for the DC fast charging, or we can say is supportable for the level 3 charging, which can solve our drawback of EV that it's make too much time to charge the vehicle. Along with all this advantage, one bonus point we are getting from the lithium ion battery, that the most of the components are recyclable. We are moving towards the EV because of the pollution and parallel scope of the technology, but we can see that the battery is again a purpose for the recyclable components. Most of the components in the battery are recyclable, which is beneficial for us, and you can use the mostly plastics and whatever the carbon materials are used in that battery, it can use again. Why we prefer the lithium ion batteries? Because we have many of the batteries just like nickel battery, lead acid battery, but in the lithium ion batteries we can use the most of the charge which are present on the batteries. So if you're having a battery charge of 80 to 100%, so you can use 80% of the battery easily as compared to lead acid battery. And if you can charge the battery, and you will get only 40 to 55% of battery charge. So while it is charging, lead acid batteries are connected in string, but it takes too much time to charge. Whereas in lithium ion batteries, it is good in string, so it can charge fast. It can support the cell balancing system and it can charge the fast. Where lead acid battery, if we charge the individual cell, the over voltage can damage the cell, which can damage the duty cycle of lead acid battery. For to cell balancing, we are using sophisticated charger. Like in your home also, you can see that the inverter connections, we have to apply for the directly. We don't use that battery supply. Like for the lithium ion battery, we can use balancing cells, which is providing in the BMS circuit itself. We use the BMS for the cell balancing, which are again the different configuration of active cell balancing and passive cell balancing. But let's move toward the discharging part. In discharging part, lead acid battery go up to 0%, and some of the duty cycle will have loss, but still you can charge the cell easily. You can replace the distilled water which are present in the lead acid battery. But in the lithium-ion battery, one is the drawback that if you go that beyond under cutoff voltage 2 volt, it may be the battery you have to replace, or it make a major issue in your system. So we will move towards the key parameters of the lithium-ion battery. In the lithium-ion batteries, the main parameters are nominal voltage, capacity, energy density, and the C rate. In the nominal voltage, we will see the output voltage we are getting most of the time from battery. Means a battery having a cell of 4.2 volt output supply, where we will see that the maximum time we are getting 3.7, 3.8 voltage from that single cell. So that cell having a nominal voltage of 3.7 volt. Let's move toward the capacity, which indicates about the store of charge which is present in the battery and how much charge it can be delivered by a single battery or the battery pack. Whereas energy density shows the amount of energy stored in per unit of mass, whereas power density shows the battery can deliver for the per unit of mass. There is a major difference between where the battery is taking and where is the battery is delivering the output power supply. And the most important part, if we will also see this in the simulation part also, C rating. C rating describes the charging and discharging time which is given by the manufacturer. While the manufacturing the battery, this parameter should be always be noted that this battery may be in how much output supply we are getting from the battery pack. So it can maximize your discharging time, and it will indicate about your battery efficiency and the lifetime also. So we will move forward. So I want to ask a single question about the lithium-ion battery only. Which of the battery is not an advantage of lithium-ion battery? Why? So the options are visible to all of your screens. Can anyone turn your mic and say that what was the reason behind it and why you have chosen that answer?
Low self-discharge rate, sir.
Low self-discharge rate. No, it's not correct.
More expensive.
More expensive. The question is about not an advantages. The lithium-ion battery is more
Specific energy or density.
No. Correct answer is more expensive. I'm asking about not advantage. Means it's a disadvantage of lithium-ion battery, because this all advantages are coming in the one single battery. So while the manufacturing is cost goes high, so that's why it's a more expensive. So we will see the battery pack simulation part. In the battery simulation, we will see about the C rate calculation and how much a battery pack can distribute state of charge was remaining in the battery for some interval of time. So to understand that C rating battery pack modulation, we have to understand what is the C rate. C rate describes about the rate of charge and discharge relationship between the capacities. We can take an example of this flow of water also. You can see that in the right side, there are 3 tubes, and the outlet part, there is a huge difference. You can see that in the first C, the small size was given, where 2C is having a more efficient and outlet side should be a more higher, where 3C having a fully open. So while it discharging, the time taken by the tubes are different. And you can see that while we can refill the water from same hole, so it will also take that much time to refill the tube also. like that only the battery C rate works. Suppose that I will take a battery of 100 milliampere, means 1 ampere battery. If its battery C rating is 1 C, means it will take a 1 hour time. Where if we take a battery of 2 C, so it will take a less time and same efficient output. For 30 minutes it will take, where I can see that for the same battery which is having a 0.5 C, so it will take 2 hours to charge, and it can deliver the energy of half of the battery. So for that also we have to understand the calculation part. Why always we are seeing that battery capacities are in ampere hour? Can anyone say that? What was the reason behind that always batteries are indicating in ampere hour, AH?
It is tested by the
Charging
Okay.
and discharging.
No.
It delivers that much ampere for 1 hour.
Yes, that's was the correct answer. Basically, current means charging per second, and the charge unit is coulomb. So while measuring the current of battery, we can see that charge per second means a coulomb per second energy is stored in the battery. So we will calculate when we are see that how much battery is charged is present for that much time. So we'll take the first equation. You can see that current is charged into second. Where if I want to measure the charge, how much charge is stored capability in the battery capacity, so I can use that current per second, and that's why the current ampere is denoting, and where for second we are using H. So that's why the battery is always converting in ampere hour or milliampere hour. For example, a battery is having a capacity of 20 ampere hour. Whenever you can study in the book or in the theoretical knowledge, you can see that it means to say that it can deliver a 1 ampere of current for 20 hours, or it can deliver a current of 2 ampere for 10 hours, or 20 ampere for a 1 hour. But in practically life, it is not a correct accuracy. But generally the battery capacity depend upon the discharge rate. Maybe the battery discharge rate is up to only 10 ampere only. So the battery is 20 ampere hour, but it can deliver the output voltage at maximum output voltage up to 10 ampere only. So this is fixed by the manufacturing side. So for the C rate also, the batteries are manufactured by the company. It provides the battery rating that it's having a 1 C rate, it's having a 2 C rate, and as per you are moving, then the battery is fast charge, and you can use the battery for discharging purpose. Also a high amount of current you can draw for their circuits, where we can see that 0.5, 0.2, 0.75, 0.25, it make more time. So I start with the calculation part of the lithium-ion battery. So this is checked by one of the formula. In the formula, you can see that CR is equal to I by E, where CR is denoting the C rate, I is denoting the current, and discharging rate should be in the ampere, where the rate of energy of battery means the battery capacity should be there. And it is always be in ampere hour, not in milliampere hour. So we always have to convert the milliampere into ampere hour. For example, I can take that a battery of 200 milliampere hour, 200 ampere hour, and the current can draw, it's only 50 ampere. So while putting this in the formula, you can see that I am getting 1 by 4, means a 0.25. So this battery is having a C rate of 0.25. Where I want to check that the battery in minutes or in calculation, you have to use that 1 by CR. T is equal, how much time should be taken, you have to convert into 1 by CR, where if you want to take in minutes, you have to divide by 60 by CR. So this battery indicates 0.25, means it take a 4 hour, and in minutes it's take a 240 minutes. So this is one of the manufacturing photo where the company is branding it already the C rate at the time of manufacturing while is sensing the how much the battery efficiently discharge. So we will move toward the software part. In software, we will going to design a battery pack for a 44 volt, and the current ampere should be a 20 ampere. So we will design in the simulation MATLAB, and I hope you will know about little bit about MATLAB. So it is easy for you also, but still I will give some little bit introduction on the MATLAB. So we will move forward. So MATLAB software is invented by the great mathematician and computer programmer of Clever Moller, and it is highly based recommended for the engineering students and for the research purpose and the PhD scholars using for the responding, check the data, and it can analyze the data and it can see a virtual output to us before we are analyzing in real life. So it is best software which are using in electrical wiring to design the vehicle body, or we can see the mathematical calculation into real life implementation. You can explain the mathematical equation using this software, and the key features that you have to know about while you have to writing a matrix code. Have to know about the matrix language. Means you have to know a basic C language also, or what are the predefined library functions are used in the MATLAB. So you can use that and you can easily import the components from the library to the simulating file, and you can easily see the response as per your time. So you can see the whatever in 1 hour, how much the SOC is remaining in the battery, like that. So we'll move towards the software part. I will explain that this was the command window where we are writing the command for the integration part, for the calculation part. You can self-design your calculator and so on. Move towards the second part is the Simulink design. In Simulink design is a platform where you can import the components from the library function, just like a PID controller, H-bridge rectifier. You can easily design any of the electronic circuit. Just you have to know about the rating, whatever the ratings you are using for the circuit. And you can draw this circuit in the simulation platform. There is a library browser also. In the library browser Simiscape, Simulink, algorithm, PID, real implementations, and the communication toolbox, fixed point designer part, every having a different signal response components are there, just like a discrete signal, continuous signal, or a triangular waveform signals. So you can use these signals in this platform easily, and you can draw the simulation part, and you can easily having a simulation button, play, pause, which are very hand-free software you are using in the while designing pack. So next I will start with the software part. So I have to move to the software part. So I have to keep wait. So this was the command window where we are writing the textures part. We can use the algorithm designing part in the command window, and you can see the response here only. This is a simulating process where we are going to simulation part. So I will use a blank. Let's take a mind second. While designing the battery pack, the first thing we have to keep in mind that we are going to design the battery pack for 44 volt and 20 ampere hour battery. So I will take a battery first. No, this battery will not show the SOC directly. So I choose the different one, battery. You can go and search the components from here also, from library part also. I will show you one of the component. If you know the component's name, you can directly type it and will get the components. So here you can see that I typed the battery. So there are normal battery, table-based battery, so it can have a different type of response signals. And you can also change in this battery internal resistance. But I choose this battery because in this battery, you can easily show the SOC of state of charge and current and battery voltage response from this battery. So I choose this one. I hope you will all know about the series parallel connections. So if I take a battery nominal voltage of 3.7 volt, here I can choose that there are different batteries as per your requirement. You can set the battery, but I'm choosing the lithium-ion one, and I will giving the battery voltage of 3.7 volt, and I will give directly 20 ampere hour for this battery. So to design a 44 volt output, how many numbers of cells are required for this battery pack? Can anyone say from audience?
12.
Or we have to connect this batteries pack in series or parallel connection?
Series.
Both connection.
Both is not a right answer because I directly set it that 20 ampere hour in the parameter. So I don't have to connect that battery in parallel connection. In series connection, voltage are added, whereas in parallel connection, current are added. But I given a simply each of the battery of 20 ampere hour. So you don't need to connect the batteries in parallel connection also. So I simply copying this for the so I set all the 12 batteries, 1, 2, 3, 4, 6. Okay. So now it's time to connect connections for all the battery. Positive to negative. It will take few minutes. So I designed the battery pack. Now I need a continuous power supply. So for that I use power GUI, and now my battery pack is ready. So to measure the voltage and current, I need a voltmeter and amp meter, and I also need a bus selector, because in these batteries we can easily see the response signal of the each of the battery. So I can choose bus selector. Here you can see that there are different parameters of the battery of cell pack. So we only need the SOC of the battery. So I remove all the, and I selected the SOC and I use the SOC part of battery. Now I need to measure the current and voltage also. And I also have to apply the load, because until we can't apply a load on the battery pack, we can't see that current. So I use the RLC load. I choose the resistive load across the battery pack. Okay. I directly get the positive supply from here. But while measuring the current, we always connect the ammeter in series connection. So I have to connect this in series, and voltage should be always measured in a parallel. So I have to connect the voltmeter as a parallel across the load. So I have to give the negative supply. So to see the output, I need a scope or display. I choose the display. This will show about the SOC of the battery pack. This will show about the current of the battery pack, and I will give the resistive load of minimum 2.5 ohm and see what happened for a 0 second. And the most important thing that this software work on the seconds. So you don't like write 1 hour or 30 minutes. So you have to always put the values in seconds. So now it's an initial condition. So I use with a 0 seconds, and I start with the simulation process. And I will see that how much battery output voltage. It's near up to 44, or maybe it tolerance level go up to. And I will see the current part also from here and show the battery's state of charge. So you can see that I'm getting a SOC of 100%. So my battery is fully charged, and I'm getting a current of 20 ampere, and I've connected across the voltage. I have decided to get the output voltage of 44, but it's good. I'm getting a 51 voltage output supply. Now suppose that this battery pack is of 1C. 1C means it take a 1 hour to properly discharge the battery. So I start with for a 30 minutes. 30 minutes into seconds, so we have to 30 into 60. So it's 1800. So how much battery is discharged in half an hour? I will give the battery response of the 1800 and I will see that how much energy is still remaining after 30 minutes. So you can see that the remaining part is 52.
What is the RLC load?
RLC load is now is 2.5, but now I will have to change the also as per the maximum output load. So I have to do the calculation part also. I will show you.
Sir, which block you have used for SOC?
Bus selector.
Okay, sir.
So I start with the calculation part. Simple calculation of a Ohm's law. I choose the nominal voltage of 3.7 volt and I connected 12 cells. So it's giving, as per the theoretical knowledge, it will give a 44 volt output. So now voltage is directly proportional to current. V is equal to IR. So I already have a current. So I need the resistive load for that circuit. So I divide with 20. How much I'm getting? I'm getting a 2.2 load. So the maximum output for this load should be a 2.2 volt, 2.2 ohms. So I have to set the resistance value of 2.2 ohm. I'm set it nearly 2.5 only. So I'm getting a correct answer. I connect 2.2 volt, 2.22 ohms. Okay. So now I again the simulation process start and I will see that for a half an hour, it's how much battery is remaining. So for after the accurate load, you can see that after the half an hour, I'm getting 46% as a remaining percent. And if I want to see that, I will give a 1 hour, means 60 into 60 sec. For the hour, it's a 3600 seconds. So while simulating, it may be a 0%. Yeah, for 1 hour, it's maybe a go to 0%. Or you can also take this battery pack as I have assumed that this battery pack of 1C. But if the battery pack is having a different parameter like up to 2C or maybe for 0.25. So as per your requirement, you can go for the designing part of this battery. So we'll move forward. I hope you will get the circuit part.
Sir, how to design 2C battery pack?
So you have to change the output overload voltage. Means the maximum output loaded drawn from the requirement for the circuit. The battery's output loaded up to only 20 ampere hour, means it will give up to 20 only. Suppose many times there are batteries are having a 300 ampere hour, but the output load, the output draw current should not always be it's not more than 100 hour. It's always be a less of 50, 60 ampere hour only. So the battery pack C rate is always designed by the company and it will always indicate in your battery. But while some time you can't see that or you can check that what was the time duration of discharging and charging of your battery. So you can check that parameter through the C part calculation.
Sir, one question here.
Yes.
Each battery, how much capacity?
For LFP cells, it's a 4.2 volt.
4.2. So how to select this battery 12 volts, 12 batteries? Can you tell me that find out how to find out?
You can see that, okay, you need the series parallel connections. Like that, I will
How
show
to
you
select
that
message?
I can choose one battery, okay, from its library file. I choose one battery and I will see that this battery is you can use for the nickel battery or for lead acid batteries performance as per your testing. So I will choose that lithium-ion battery. And the battery nominal voltage is 7.2 is already given, but we are using lithium-ion battery. And lithium-ion batteries maximum time is giving a 3.7, 3.8 voltage as a nominal voltage. So I choose that battery nominal voltage means I will get minimum 3.7 and 3.8 volt from each of the cell. Okay. So I will choose 3.7 volt and I take in a 20 ampere per hour for this single cell. Okay. So each of the cell is 3.7 volt and I want to generate the battery pack for a 50 volt or 44 volt only. So I simply calculate this 44 volt divided by 3.7. No. Multiply by 12 volts. So I'm getting 44 volt 0.5. So I choose the 44 volt. Suppose I like to go for the 50 or maybe a 48 volt. So I have to go for the 3.7 into 13 or 14 volt maybe. So 48, we are getting a 48.1 volt from the 13 number of cell pack. So we have to connect this battery in the string connections. Whenever you can see that battery pack design, you can see that aluminum strip is connected. Alloy strip, nickel alloy strips are connected to the each of battery. And if the each battery is having a 3.7 nominal voltage and 200 milliampere hour battery. So 200 milliampere means a 2 ampere battery. So if I need a up to for a 10 ampere, so I have to connect the batteries in parallel connection. And for the series in series connection, you can add the voltages. I hope you are clear.
I have a question here. Can you show us an example of a charging simulation? This is a discharging simulation that you did, right?
Yes.
Can you do a simulation for charging too, please?
I will show you the single battery power supply which are giving from one battery to another battery. Okay.
Sure, yeah.
This battery is providing a 12 volt as a nominal voltage and internal resistance is 2 ohm. And the dynamics are fixed. No dynamics I need. Variable charge. Yes, I need a charge of 50 ampere. Okay. or I can use DC voltage source. Yes, DC voltage source is also providable. So I need a DC voltage output supply for a 12 volt. Okay. I will see the signal response to you. There are 3 signals. You need bus selector. So I initially show the initial condition with the graph. First one will show you about the SOC of battery, how much current is having a battery, and what was the voltage capacity of the battery. Okay. For this, I need a continuous power supply, power GY. So now this battery is 100% charged, but we have to decrease the charge, or the initial current should be a 0. And the battery is already set up to 7.2 nominal voltage. So it come under, I can elaborate it from here. You can see that it's more than 5. It's around 7.2 or 7.5 output voltage we are seeing here. While we are connecting to the load. Suppose I take a load of R of 1.5. I connect it with the battery. Again, I do the simulation for 0 second. Now you can see that my state of charge was still 100% because it is an initial condition. 0 second means it's a turn off. So I have to give some seconds, like I will give 10 seconds. After I have applied the load, I will slightly increase the duration of time, that 36 hour, or maybe I will take a battery of 1800. So you can see that there is a slope of state of charge. It's a 50% battery is discharged. And now I start connecting the power supply to the battery. First, I have to convert the battery supplier as a analog converter, and then I have to provide the battery supply of to only 7 volt, because this battery condition should be a 7.2 nominal voltage. So I have to give the current, the voltage limit should be at that much only. So I change this 12 volt to 8 volt. And now I connecting the power supply. Okay, this is not for the PS Simulink. So I have to convert this response into real time and software time. So I have to choose the PS Simulink converter.
Sir, I think you are using sim block. So
What?
I think you are using sim block. Kindly use Simulink block, sir. I think that is the issue. It's not connecting.
Yes, I use that PS Simulink. Now I have to use the what was the problem in this?
In the SPS library, if you look for
Yeah,
a
I
voltage
choose
source,
the source supply.
Sir, I think you should use that DC voltage source from that DC voltage.
Source code is showing
That
about
last one DC voltage source.
maintain the software for the terminal and define the constant parameter. Okay, it's not suitable. I have to restart the system.
Hello. Hello.
Hello.
Jayji, am I audible?
Yes, yes.
Yeah, I have one question. Can we control,
Hello.
Can we control the charging or discharging current?
Hello.
Hello. Jayji,
Yes.
can we control the charging and discharging current?
Can you speak loudly? Your voice is not.
Yeah. I am understanding that can we control the charging and discharging current?
The current should be depend upon the load. If the requirement of the load, it's a current and load is directly proportional. While the load is increasing, the current drawn from the battery should be increased. And we directly can't control the current from the battery.
Okay, got it.
We have to need a controller circuit to control the.
Yeah. Also, one question is there. Suppose
What?
here we are showing a voltage source, okay, for
Yes.
charging the battery. If we are using a current source for charging the battery, what would be the difference?
We are generally using the power supply, electric power supply, which is AC power supply, which convert into DC, where we will see that the voltage supply.
Yeah,
And
suppose it is a solar panel, right?
okay,
You know, some of the here also
Krishna, your voice is too low and it's breaking also.
solar
Can you
panel.
repeat it or? Yes, for the solar panel.
Yeah, solar panel will act as a current source. Huh?
Yes.
I want to charge my battery with solar panel. How is
In the solar panel, you can see that the each number of cell modules in the solar panel itself will give a 0.6 volt supply. And while you connecting in parallel connections and series, we will get the output voltage of up to in the one panel. In the one panel, we will see that 1.
Hello, sorry to interrupt.
Yes.
I think that it depends upon the charging mode which we are using. If we are using constant voltage, constant current, so in between it depends upon the charging method which we are using.
Maybe it's a sophisticated charger, or we are using direct from the BMS supply. So which can take monitoring on the lithium-ion battery while it's charging, how much limit should be for the charging purpose also. But for the solar panel, it's a different part.
okay? I just have one question. That if suppose I'm charging my battery with solar panel, okay, and
Okay.
like a single solar cell is giving 0.5 ampere current.
Okay.
Now I'm connecting around suppose 18 cells to get 28 volt supply voltage. Okay, my nominal voltage is 28 volt, and the current which will be coming from one string will be 0.5 amperes, because if the cells are connected in series, they are giving same current. So if I am having 0.5 ampere current, okay, so like basically voltage is required for nominal voltage, like battery's nominal voltage and the panel's nominal voltage should be same, isn't it or not? Or it should be
Last
more?
half of your word is cleared and it's audible, but the last, whatever the sentence you have said is not perfectly clear. So, you can repeat the question, right?
I'm just asking that my battery nominal voltage is 28 volts.
Okay, 28 volt.
Yeah, so my solar panel voltage should also be the 28 volts. Right?
Maybe it's in practical life always be a range. You don't get an accurate voltage from the outer source, or we are providing an exact output voltage. So maybe it's up to a rating of 30 volt or 30 volt to 45 volt or 50 volt. Okay, so you have to select that choice as per the range. The value, whatever you want, you can change, choice the component as per the range, and you can use that component for that.
So how I will be deciding my current, that how much current is required for charging my battery?
Hello.
Easy.
Current flow from the high potential to low potential always.
Okay.
Okay. So
Hello, sir.
I will move ahead. Hello. Yes.
Yes, sir. Good evening.
Yeah.
Sir, in previous simulation, discharging of the battery, you have provided 20 ampere hours. So I think that's a capacity of the battery and not the C rate, right?
Yeah, capacity of battery should be in ampere hour. I assume
Yes,
that
and
designing simulation pack I assume that I have designed a part of 1 C rating of battery.
yes, and there is no possibility to design C rate in that particular battery model, right?
Yeah. It is manufactured by the company that each of cell which having a discharge rate. As per the discharge rate, the C rate is there. You can see the only battery and you can see the output calculation part. That how
Okay,
much battery is getting an efficient output.
Okay, and sir, another question. We had connected 12 cell of 3.7 volt battery in series. So the equivalent voltage should be 44.4. But why we are getting higher voltage than that?
Basically, there is a lot of difference between in real scenario, practical and theoretical part. But still, we have connected the load supply and some of the sub-circuit of the current measurement and voltage measurement internal resistors are also present on it, which can increment. So whatever the output you are needing, its answer should be getting a nearby it. So I'm given a 44 point volt as per the theoretical knowledge, but while I am connecting to the ammeter to measure the current, where we are measuring the voltage, and I also applied the external load of 1.5 ohms. So subsidiary output of tolerance should be a positive and negative of 5%. So that's why I'm getting a 51% voltage output.
Yes, sir, but all the components like voltage source and current source are ideal in MATLAB, I think.
Yeah, that is ideal condition, but the inbuilt part of that battery internal resistance should be also a different. I have not changed the internal resistance cell of the battery. For that, I have to use the another battery of electric preference, and I have to choose the internal resistance, and I have to adjust that.
Okay, thank you, thank you.
Okay. So
I have one question.
okay.
In battery terminology, we use the terms rings and strings. Can you elaborate the differences between these two and what they mean?
Can you explain the question again?
Yeah, in battery world, we use the terms repeatedly, strings and rings for bigger battery packs like 300 volt, 600 volt battery packs. So can you shed some light on these two terms and point out the differences?
Yeah, while cells are connected in the string, should be in series connections. Okay, maybe in series parallel connection, but it's completely a one cells are connected to each of the positive cells. While you are charging the string connections, you always need in lithium batteries BMS part, where we will provide a passive cell balancing or active cell balancing as per the BMS architecture. You will getting that. But while in the ring system, the battery is connected in the loop connection, and one of the part where always be a connection should be a loss. And the ring system is helpful for to indicate the fault of the battery. If it's connected in ring and one of the circuit which will break and it will not flow the current out, it will not flow the sufficient efficient voltage what we are needing from the battery pack. So it can easily be detected and it can sense by the BMS only. So we can't prefer the ring system in daily life, or in the EVs also we are preferring always the string connection only. So I hope you are clear, and I will move towards the protection part of the BMS also, protection part of the battery, lithium-ion batteries also. So I start with the lithium-ion batteries. I need 6 only, but I will take this topic another day. But I will give a sub overview of the part. Why lithium-ion batteries are still very much dangerous also, because of the part of while charging and discharging part. because we can't go beyond to the 2 volt. If it's go beyond to the 2 volt, duty cycle will damage, and it can also the cell damage loss also. Maybe overcharging also happen a swell, or up to overcharging can maybe exploit in the lithium batteries. So for the protection of ourselves and for the increase the life of battery, we are using BMS. Okay, I have to start with here. So battery management system, from name it only indicate how it's about it managing the battery system, voltage, current, and temperature also. And you can see that whatever the connections of hardware part of the circuit is responsible by the BMS system only for the battery pack. It is also called as a battery doctor or a hard part of the battery system. Where battery type of BMS is also having a 2 types, hardware BMS. In the hardware BMS, basic functions are given to that circuit, that how much output voltage it can break down the circuit, or how for the safety of the battery also, it can't go beyond to the dead zone, or it will provide a continuous current detection should be possible. Where in the smart BMS, the additional functions are given, where the additional function we can use to store the data. And you can see that while battery response now in Nexon also and in Comet also, the battery state of charge is displaying in the dashboard. So it can share the data through the CAN bus to the user, who is how much battery is remaining and how the way of charging while the regenerative braking, we can see that. And by the additional function, you can see that you can change or detect the fault battery from the battery cell pack, which is the best part of the advanced or smart BMS. It also take the data and it can evaluate, and as per the recommend, it can run the thermal runway. So these are the basic functions which we are going to have to cover on this, but the software time is taken too much. So this was the picture of one of 16S 12S BMS. This was a picture of our center only. The each cells are connected in series connections, and we will getting the output voltage from this is 3.7 to it's up to a 48 volt only supply. We are getting output from this battery pack. Here you can see that first yellow box is connected, which are resistors. And at the back side also in this circuit, the transistors are connected, which is using for the active cell balancing part. There is a electronics part where it is used for the IC, and for the safety of ICs also we have connected RNC circuits. In this yellow color box shows about the discharge of the MOSFET, and red color of box will show about the charge of MOSFET. We can easily identify while the shunt reactors are connected to the MOSFET, which are using while in the discharge part and which are using for the charging part. So you can easily identify it.
Yes.
I ignored. Yes.
I have one question. What is the what is
Hello.
Hello. There is the am I audible?
Yeah.
I just wanted to ask that active balancing and passive balancing in this circuit, how you are identifying that this is an active circuit or a passive balance?
While in there the connections, because in each of active balancing and cell balancing, in the cell passive balancing, all are the circuits are connected with the resistance and the capacitors. Where in active balancing, we are using the transistors to connect the each of the cells. From each of the string connection, from while the positive and negative connections are in the between of the each of the cell, we are connecting one of the wires to the from the BMS, which we will take the response and output voltage, which can sense from that. So while the seeing that object only, you can decide that it is an active balancing part are there, because in this in this BMS transistors are connected. So it is transistor are connected to the each of cells, where we can see the NPN transaction semiconductor for the switching part. So it's an active balancing part. And when it's connected only for the resistance and the circuit and diodes for the amplification and cutting part, you can use as a passive cell balancing.
If capacitor is there in the circuit, then it is called passive cell balancing.
Yeah, it depends upon the architecture of the BMS also.
Okay.
So I will skip this question. I will move toward the additional part of the BMS. The additional part will sense we can display the state of charge. We can see the monitoring on the depth of discharge of the battery also. Communication interference, I already explained about that. Cell monitoring diagnosis means a fault diagnosis is easily possible in the smart BMS. So this is another picture of smart BMS. In the smart BMS, there are possibility to check the thermal power. Thermistors are also connected, and the CAN communications, or you can directly connect to your phone also by Bluetooth, and you can see that whatever the cell, each of cell having a voltage, and as per the how much output voltage you are getting from the battery pack. So this feature will help a lot for project work and the research part also. So we will move toward the hardware of BMS. In the hardware BMS also, architecturing the categorized into two parts of component, active components and the passive components, where we are using IC, as we know that ICs are microchip and it is performing for the specific tasks. And here we using the IC for the higher accuracy and the monitoring on the BMS, where we are using a MOSFETs while for the charging and discharging part only. And it is also provide a potential for the BMS, where I will move toward the passive components. And in the passive components, the resistors, capacitor, inductor, and diodes are coming, where resistors are used to the resist the flow of current, and it is using for the cell balancing, protection of the IC also. And we use the capacitor to predict and increase the battery life of maintaining the battery system. It is a part of electronic circuit design. And we use the inductor, and the inductor is also known as a shunt reactor, which is this one. These two shunt reactors are connected to the discharge of the MOSFET, which is always connected to the discharge MOSFETs only. And we are using a diodes. We are using the diode because of the regenerating braking. While you can see the state of charge, whereas a curve part is also showing in the state of charge. So that curve part always indicates that while the vehicle is accelerating, you can see that a constant road, or when you are applying a brake, there is some energy is generated by the regenerative braking system, and it can flow the current or voltage as per the requirement from the diode, because diode only work on the forward wires, and we are always we take care of the reverse current which is obtained by the regenerative braking. So that is end from my side. So I want to wrap this session also, and the time is, I hope, gone. But nobody, if you want ask any question, you can free to ask the question also.
Yes, sir. Thank you. Your session was excellent. Thank you so much.
Thank you.
Yeah.
Thank you.
Under the BMS topic, what was the text? Under the BMS topic, what kind of advanced research is going? Okay. In the BMS part, research part is going that it can, as per the smart BMS, there is a lot of algorithm function it's present in the BMS. So we will shorting the algorithm and we will get the efficient output. Because you can also see that before we are not moving towards that electric vehicle move on, but the Ola has launched a scooty, and due to certain heat or due to the BMS architecturing, there is a burning on the Ola scooty only. So while we are recommend a high configuration BMS software smart BMS only for the, because we are sweeping the battery in the scooty. So it is good for the smart BMS part, and we can already the algorithm function part is still in the process because it's a very complex part. So for the better understanding, we have to know about the BMS algorithm. First, we have to understand the BMS algorithm, and we will move toward the research part also. Can we get the PPT? Sorry, it's not for the cerebral sharing the PPT. Thank you. I also enjoyed this session to deliver my experience to you all.
Hello, sir.
Thank you very much. So wonderful.
Sir, can you share feedback from?
Yeah, feedback form is shared by our team. So please, the team, take over it.
Okay, hello listeners. Thanks for attending the webinar. Hope you all like the webinar and looking the exposures to enhance your learning and skills in the same domain. Okay, so do reply one question that does this webinar improve your understanding of the topic?
Yes, sir.
You can
Yes,
comment
sir.
yes or
Yes,
no,
sir.
or you can raise your hand if you feel this webinar was helpful for you and your learning. Okay, great. Thanks for your response. So here I would like to introduce ISIE India products, which will help you enhance your skills. So come take a look of a small video about ISIE India courses that helps to enhance learning and gives the opportunities for the placement. Okay, have a look through the video.
Hello engineers, do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industry projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab, and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, AV machine cutout section workbench, two-wheeler, three-wheeler, four-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off-grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions, and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Thanks, learners, for watching the video patiently. Hope you guys have understood the products. So, any of you wants to enroll in the course or interested in the course, kindly send us the inquiry through a QR code sharing in your screen.
Ma'am, there's a small doubt.
Yes, ask.
For the feedback link, you have sent the Google Maps. Why is that so?
Okay, for that, you have to do the Google review. You have to mention the review of this webinar.
Yes, ma'am, but I have done, but link is not opening again. I have given the review.
Hello.
Hello, yes.
Sir, actually, could you please resend the link, feedback link in the chat box?
Okay, I'm sharing again. For who are saying that link is not working, copy this link and open in your Google Chrome.
Sir, one doubt, sir. We are asking for feedback link. You're saying sending the Google Maps link.
Like you have to write a Google review of a webinar.
Okay.
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 This is not a Google form. You have to write a Google review. So copy this link and paste it on your Google Chrome or any other browser. You can do this.
Sir, it is asked the photos, sir. I had photos. What one?
No, you don't have to. You don't have to add a photo. There is a section of write a Google review or a review button.
Okay. Then I will click on the post button.
Yes, you can only write a review. You have,
Okay.
It's not necessary to upload a photo. And anyone wants to inquire about our courses, they can scan this QR code and you can submit your form. Okay. This is for course inquiry. Then who have filled the Google review, you can leave for this meeting. Okay, and the certificate will be shared on your mail. Just copy this link and paste it on your browser. Then this link will be working.
Hello, sir. Good evening. I have one doubt, sir.
Yes.
Sir, on July 22, I was attended one webinar, Introduction to Power Electronics on MATLAB, sir.
Okay.
But so far I have not received any certificate, sir. But it will give some steps, sir. Click on the register log button, and then after login, click here, and then click on start course, and then click on complete button. But I followed these steps, sir, but I'm not able to get the certificate, sir.
Like first you have to log in yourself. Okay.
Okay, sir.
Then after the login, then you have to open that link which is shared to you for download certificate. Okay. You can open this link on a new tab. Okay. Then after opening this link, you will redirect it to the download certificate page. If you want to watch the session video, recorded session video, you can also watch that.
Okay.
Okay. And then you click on the complete button, then you will get your certificate.
Okay, sir.
Can I have feedback link, sir?
Okay, but I feel somewhat difficult, sir. Straight away, if possible, you give the certificate for straight away, sir.
Sorry, like I can't understand this.
Sir, sorry. You give the 4 steps for to get the certificate, sir.
Yes, sir.
Yes, sir. So I want why this complication? Straight away, you give the certificate to mail, sir.
Sir, because there is a reason for that. We got a registration about 1,000 plus. Okay. And if everyone wants to certificate for a single, then this is not possible. So we have generated a AI software on our website.
Okay.
That generates automatic certificate for you. For that, you have to log in this.
Okay, sir. One more doubt, sir. I attended 22 July, sir, but I have not received the certificate. But after, may I take the certificate at any time, sir?
Yes, you can take certificate anytime.
Okay. Thank you, sir. Fine, sir. Thank you.
Is feedback is mandatory for certification, sir? Hello.
Yes, sir.
Is feedback is mandatory for get the certificate?
It is a for our like for a wealth, you can give feedback so that we can improve us better.
Okay, it's okay, but it is not mandatory, no? Or what?
Yes, no, sir, it is not mandatory.
Okay, sir. Thank you, sir. Thank you very much.
Thank you. This is not a Google form. It is a Google review. Like you have to write a review for us, like how you are feeling about the webinar. Okay.
That is done. And when the result will be just sent to us.
Sir, your voice is getting echo. Can you please switch one mic from your device?
Closing one. I think it was on the.
Yes, sir. Now you are audible.
Yeah, is it now? I'm audible to you?
Yes, sir. You are audible.
Now, when you are going to just mail for the certificate?
Sir, we have like generated the AI on this, and the AI works at the 9 p.m. today.
Okay.
You will get a mail.
Okay. No problem. I've already filled your review, Google review. And,
thank you, sir. Very much. Thank you. Just copy this link and then open in your browser. Then you can click on the Google review button. Just copy this link on your on your clipboard, then paste it on your browser. The certificate will be shared by today 9 p.m. on your mail. If anyone having a doubt, please tell. I am ending this meeting. No, we are not allowed to share PDF. You can watch the session again on YouTube. Otherwise, we are sending the certificate download link. You can also watch from there.
Excuse me, sir.
Yes.
Sir, actually, I had logged in with my another mail, personal mail,
Okay.
and when I copied the link and I searched it on the browser, my mobile
Okay.
taking as like default mail is another one, sir.
Default mail. Okay, it's okay. There is no issue with that. If you have registered with that mail, then we will share the certificate with that. Okay.
Okay, sir.